Hello everyone. So today we have a medium problem. Find largest value in each row. What we are given is given the root of binary tree, return an array of the largest value in each row at each row of the tree. Zero indexed. Zero indexed. It means like this list, and at zeroth level we have the maximum value of one. At one first level we have the maximum value of three. And at second level, like 0, 1, 2, 2, we have the maximum value of 9. Okay, so let me explain how it goes. 1, 3, 2, 5, 3, 9. Okay, so we have this binary tree 1, 3, 2, 5, 3, and 9. We have this kind of a tree here. Okay. Now, there are two types of traversal methods, right? Like one is DFS and one is BFS. So, in this video, we will be covering the DFS method. So, what is DFS method? We go through like depth at each level. First, we will go through the left and we will go through the right. Then again, we will go back. Then again, we go to the right node. Okay. Now, let's say what we need to do here. We need to traverse at each level. Let's say we have this level as 0, and this level as 1, and this level as 2. So at zeroth level, we have 1. At first level, we have 3, and at second level, we have 9 as the greater element. Okay. Now, what we'll be doing is we will be creating an empty list. Okay. Now, what this empty list will do is this will cover all the maximum element at their respective indexes. Their respective indexes will act as the levels. Okay. So the zeroth level will act as the greater element at the zeroth level. First index will act as the the greater element at level one. Okay. Now, what we'll be doing is we'll be going through each level and we'll be populating the list. And okay, that's the basic idea. Now, how will we populate list? Because at the start, the list is empty. So what we'll do is we'll check like if the length is our length of, let's say our this list is ls. So our l- length of list less than or equal to should be less than or equal to, I'm sorry, should less than or equal to our level. Okay. Why this is? Because let's say we are at level 3 and the length is 2. So it shouldn't work like that. So even if this condition arises, what we'll do is we will add some kind of negative element in the list, and then we will replace it with our current index. So what I mean by that is for currently like our level is 0. Okay. So 0 level, let's say level is currently 0. And our current length of list is also 0. So currently, we do not have anything to replace in the list. And the reason we cannot directly append to the list is because we are going through multiple levels. Like on the left hand side, you can see like this is a level we are going through one level multiple times. So appending simply means like we are adding a new element at the end. Okay. So at zeroth level, we will be adding some kind of new element, let's say some kind of negative infinity here. Okay. So this will be at zeroth level, and then it will check like if one is greater than infinity. If yes, then it will be replaced with one here. And we do have an index here at 0. And then again, we go through level, let's say we are at level 1 now, and the length of list is again here 1. So it's greater than or equal to, we will add some kind of minus infinity here. and we go through this level. So our path is like this, right? So 3 we have first, so we will be replacing the minus infinity with 3, and we have it at 1. Then again we are at 5. So 5 here minus infinity because of this condition. So minus infinity will be replaced with 5. Okay. Now what happens when we encounter a same level at for different node? We have populated list for this left subtree, we can say. So now we have a 3 at level 2. So at some point the DFS will reach this node. So we know that which node it is, like it is 2. So it will compare 5 with 3. So 5 is greater than 3. Then the 5 remains the same. Now it goes back to again 2 here. This 2 node. So it will compare 2 with 3. So 3 is greater than 2. So 3 will be here, and then 9. For 9, 9 is greater than 5, so we will be replacing 5 with 9. Okay, so this is basic like recording of level. When we code it, like you'll get like how we are implementing this. Okay, so let's start with this. Let's say we do have a list here as ls, and we have a method named DFS. So what this method will accept? This method will accept our node and our current, let's say, our level. Now we'll do a pass for now. What we need to do? We need to call this method, and what we'll need to do? We'll here return our list of maximum elements. Okay. Now, what do we need to do here? So first we will pass our root node here, root and our current root at level 0. So when we encounter an end node, like let's say 5 here, so after 5 there will be nothing. Like if we send it some kind of none row. For now, let's say, for example, here we don't have anything. This is none. So how are we handling it? Okay. So if not node, we will simply return. Okay. Now, for this condition here, length of ls is greater than level. So let's say if our level is greater than or equal to len of ls, then simply ls dot append, we can add some kind of element here. Okay, it equals to 10 or 20, or here 20. So why I did minus here? Because like if we even compare 1 with minus infinity, the 1 will be greater. We want maximum. Okay. Now, what we will do is we will at 0th level here. You can see here that we are at level 0. So we want to add at 0th level. So ls at level should be the max function, and we will be comparing the value with itself, and then we will check it with node.val. You can check here like the dot val contains the value. Okay, so we are done with the with our root node, but what of its left and right component? We simply call it recursively. Here we have node dot left, and its level will be level plus 1. Okay, and simply it is right. I think this is pretty much it. And when we run it, you can see like it passed. And Yeah, that's pretty much it. Thank you, Ron.